before it sort of sounds not then too negative on sort of the planning aspects, etc. I do believe that you should sort of work interactively with or iteratively with your applications and start sort of by just solving your problem and sort of abstracting away from that, because usually you don't necessarily know what your problem is. However, I will state that before Christmas I did an application development course where me and one of my group members spent like 1.5 weeks on just planning the sort of API between the front end and back end. And when I say 1.5 weeks of planning, I mean actually 1.5 weeks of active planning. We essentially discussed it every day and really dug down into all the details and made sure that it was like super clearly specified and we knew exactly what we were doing. And because of that, I, who was writing the backend, could sort of create very clearly defined tests that I could also test against. Not unit tests, but whole sort of system integration tests, or at least backend tests. When we sort of, in the end, 2 days or something, before we were supposed to hand in the project, started tying together the front end and back end, almost every single feature sort of worked on the first attempt. So if you sort of have clearly defined problems and you have the time, etc., to sit down and you know what you're doing, you have sort of some knowledge about how you can best approach a problem, then sort of use time to plan, etc. However, if you're not necessarily sure on what you're doing, like if you're making a game engine, and most of you haven't done that before, or some projects like that, it's usually best to just sort of have at it and try to figure out the problems as they come, because you don't have enough experience to really know what you're supposed to anticipate and what problems you might be facing. So by sort of prematurely abstracting before knowing those issues, you will probably just end up with the wrong abstraction, which will be way more painful than having to sort of refactor stuff from time to time, because in general, dealing with sort of wrong abstractions is always a pain. So yeah. So I guess I could just give some exam tips before we jump over to the architecture that we did for our graphics exam. So we said this, I've said this each year that I've had this lecture, it's an open exam. You know, you're allowed to, it's an open exam, right? They're allowed to bring in whatever they want.
So you mean the actual project, right? 72 hours.
The exam.
Yes.
The presentations and exam. Oh, you speak about oral one. Or
no, the actual exam, the 24 or 32 hour.
72.
70. Oh yeah.
Yeah, you're allowed to bring. Yeah, you're allowed to bring in everything. Right, Christopher?
Oh yeah. Like
yeah.
it's like.
So like go and build a framework.
Everything. I'm just thinking about it.
Yeah, actually. Yeah, they will be working from home, so I don't get your question. What you mean, like bringing everything?
They can show up with code they've written before, right, for the exam?
Yeah.
Yeah.
Let's make it harder this year and suggest.
2 legible A4 pages.
Yeah. As long as you're allowed to bring code from before, that you've sort of written beforehand, go and write yourself a framework before you show up on the exam. Just to sort of, because the worst thing that can happen to you on the exam is that you finish day 1 and you have nothing on screen. And considering how sort of annoying OpenGL can be at times, that's a situation that isn't necessarily uncommon. Like it can really easily happen. You probably saw that with the first assignment, that it's really easy to make mistakes in OpenGL, and it's not necessarily very easy to find out what those mistakes are. So build a framework before before the exam that sort of has stuff that is generic enough that you can assume to sort of be able to use it on the exam. We were actually super lucky. Unfortunately, I didn't get my framework to compile because it's old. But when we built our framework, we we essentially said that, okay, what we want to show up with that exam is, and we didn't know what the exam was going to be, but we at least want to have a rotating cube with textures and full fun lighting. Just so that we can guarantee that whatever the exam is, the first day we had like, or we had something on the screen which was relatively easy to manipulate, sort of as soon as the exam started. Obviously, we were super lucky because, as I said, we showed up with rotating texture and full fog lighting, and our task was to build Minecraft. So we were essentially done sort of with the base tasks after the first day, because we just needed to figure out how we can take our cubes and place them out around in the world. And then we spent the rest of the time just implementing extra features for extra points. So yeah, build a framework that is good for hacking, sort of that can really help you in a way. Know that that framework might also come with negative aspects, because while we sort of finished a bunch of the exam early based on the fact that we had a good framework, we also spent a lot of time optimizing that framework because it was not written in mind that we would sort of be dealing with as many cubes that we were, etc. So we were not doing any form of like not necessarily culling, but essentially when we had our original framework, these sort of mountains are now like there's nothing on the inside of them. However, when we had our original framework, we would also add cubes sort of on the insides of all the mountains, etc., which completely killed our frame rate. So at least we sort of had to deal with those sort of problems. But yeah, so going from one rotating cube to a Minecraft world didn't really take a lot of time. Most of us had sort of the landscape finished by the first day, and then we just went on and did a lot of other stuff, like yeah, we have our sort of specular lighting. I think we have some, yeah, we have some rain. The most beautiful sort of cloud that's ever existed. And this was just sort of hacking the cloud as well. We're just like, okay, I want some sort of downpour just to get an extra feature in. Let's take a cube, stretch it, and then all the rains are just cubes with different textures as well. And then, yeah, so we sort of implemented a lot of different functionality, and the reason that we got to do that was just because we spent a lot of time beforehand on getting stuff up. And a sort of funny story is when we were actually setting up this framework, both me and Klaus, who I was working with, were sitting next to each other, and we were sort of writing the exact same code. The only thing that was different was the naming conventions, but everything was written exactly the same way because we were sort of developing it together. And at one point, when we were sort of finished, his program didn't show anything on screen, and mine did. And we did not understand at all why, because we had written the exact same code. And this also came into like where OpenGL, with us not checking error codes because we were never told that error codes was a thing that existed. We ended up essentially we started on the top of each file, and then we compared line by line by line. We would sort of state, yeah, what have you written? Okay, yeah, that's the same as I've written. Okay, well then the error probably isn't there. Until we got to one line where I said like, okay, I say GL uniform 4F, and then I send in this matrix. And it says, yeah, I also say GL uniform 4, and then I send in this matrix. And then the difference was just like, he had written GL uniform 4, or he had written GL uniform 4F, while I had written GL uniform 4FV. But So we added that single V at the end, and then suddenly everything was sort of working the same on both sides. And that's particularly something you want to happen like 2 days before the exam, and not on the exam. So yeah, so hopefully I'm motivated enough.
Are you using identical 3D models for all those kind of stones falling?
Yeah. Everything is the same cube, it's just scaled differently.
But is the location kind of random, or?
Yeah, the location they fall from.
Yeah.
Yeah, that's random. It's just from some place that's covered by the cloud. Unfortunately, I don't remember all the key bindings because we didn't have. So yeah, and then sort of hack as much stuff as possible to try and get extra points. So I found out that hey, you can just modify the sort of field of view, and then suddenly you have, you know, warp mode, which looks like pretty cool. As you can see, we have a super nice sort of skybox. That also is sort of done with the most dirtiest hack ever, which is also why it looks shit. Which is essentially, I didn't know how to make a skybox, but I had the box and I had a sky texture. So I just sort of said, okay, I want a giant box with a sky texture, and then we just flip the normals. No, we don't flip the normals, we just switch that we're supposed to call front face instead of calling back face, so that, you know, you actually see the box. And then, so there's a giant if statement in my loop, which is essentially just like, if I'm drawing the skybox, then flip the call face, so that, you know, it looks like a box from the inside. It still looks like shit though, because you can see the edges. But, you know, try to sort of get in, like, have fun by getting in those sorts of features. So yeah, so the architecture that we went for on the exam was, let's see, essentially that we had a sort of central rendering system. So we had our renderer, which essentially were responsible for all communication with OpenGL. And we came up with this as we were building the framework. And the good thing about that meant that since we showed up to the exam with the framework, we essentially never touched OpenGL on the exam, because we always went through it by like manipulating the renderer or making use of existing sort of functionality. So every time you wanted to render a model, you would just send in the name of the shader that you want to use, the name of the mesh that you wanted to use, texture name, the model matrix, the color, and then also like which texture index, etc. that you're using. So we managed to create a pretty nice sort of, or at least nice at the time, way of sort of abstracting away the details of OpenGL that we didn't want to deal with particularly much on the exam. So essentially the renderer was responsible for everything that was directly related to OpenGL. And then in terms of the sort of game object model, we essentially just, since the terrain is mostly static, we ended up just going for sort of scene objects type scene object sort of type OO model, where we would just give each object a reference to the renderer so that they could render themselves, tell them which shader they were supposed to use, mesh name, texture name, etc., and then have logic that manipulated that object from the outside. So these were relatively, if I don't remember wrong, they were relatively, didn't really contain that much behavior. It's more, the behavior was essentially just the minimum behavior needed to update you know, your model matrix, etc. So those were sort of where we choose to draw our abstraction sort of boundaries. In terms of OpenGL stuff, we had an abstraction around shader programs, so that we could treat them as classes. Same with the meshes, etc. However, one thing that should be mentioned is that this wasn't a particularly sort of efficient implementation. So, for instance, the way we did our meshing meant that we were always reusing the cubes. So, you know, when we had like 40 billion cubes on screen, we didn't have 40 billion sort of copies of the cube on the GPU. Which was good in one sense because we weren't using extreme amounts of memory. However, it meant that we were doing a lot of unnecessary draw calls, which we could have optimized, and I went back sort of optimizing that later as a sort of challenge to myself, and that's when I really saw how fast these sort of programs actually run, because that was really humbling to sort of go back and basically combine all the meshes so that we do the whole terrain in one draw call rather than the 16,000 or something I had originally. So yeah, any question about essentially anything?
Well, yeah, again, this exam thing was confusing. Yeah, to disambiguate, because I don't know whether we have explicitly spoken. So the exam as a whole will be like the project that you have to do within 72 hours from 3rd to 6th of May. And yeah, you will be free to like use any resource for tackling the problem. You will be working from anywhere. And afterwards on 9th or 10th of May, there will be an oral kind of exam where you will have to present what you have done, and we will be just asking some questions like about your project, what you have done, why you have done, and maybe like some part from the course theoretical stuff, like just to explain how they work. So like there will be like the exam itself, what we call it, this like practical hands-on coding for 72 hours, and then will be presentation where you have to explain everything. So that's kind of 2 parts that conclude this course. So does it make sense?
Cool. So in terms of sort of patterns, you might notice that I'm not really using any patterns that much within this project, mainly because, yeah, as I told earlier, I have been sort of burned at that point by going overboard with that sort of stuff. But we figured that this architecture was the most sort of suited for our purposes. And unless there's any sort of questions related to that, to how we handled anything.
I'm just wondering, when you're rotating and scaling, you're using like a model matrix, or?
The scaling we're doing some of it in the vertex shader, because that was part of our task, and then we're doing some of it in the on sort of the CPU side by changing the rotation around, or yeah, setting the rotation of the model, and then we just update the model matrix.
When you're saying you're doing it in the shader, do you mean like you're passing?
The scaling, we're passing the scale to the shader.
Oh yeah, because in my project now I'm just passing a matrix to the shader.
Yeah, we would have done that as well. It's just that part of the task in that exam was explicitly to do scaling in the vertex shader, basically just to force us even more into trying to do more stuff on the shader. Unless there's more questions, I could just sort of jump back to the game program patterns book and sort of come with suggested readings. I would sort of suggest reading the entire book, but I know probably most people won't actually do that. However, some patterns that I've looked at that I've really found useful is at least the flyweight pattern. Could be worth looking into now that so that you don't fall into the trap of creating as many copies of your vertices as you have objects that sort of have the same visual representation. Similarly, the state pattern is interesting, but it sort of depends on, that one really depends on whether or not your problem can actually make use of it. The component pattern should be looked into. The event queue is also quite cool. I would also suggest reading the optimization patterns because they're interesting in the way that they discuss, particularly sometimes the impacts of the patterns that are sort of having to some. And unless there are any questions at all, then I think that's essentially it from me.
I was thinking about the optimization pattern, right? The spatial partitioning, right? That
Yeah.
would work quite well, would fit perfectly into Ivo's last session as well, right? Where it's about partitioning for execution on two chillers. Or is that wrong?
It might be.
Right. The idea is to subdivide space,
Yeah.
right, for giggling whatever else, into, for example, spatial representations as here. And that was a classical problem there. How do you get the right, number of threads and the right number of compute groups and so on to optimize performance, right? So it kind of, you want to see those patterns more on a more general level. They may not just be for architecture. Well, they are for architectural reasons, but it boils down to how you use your architecture, right? So if you, for example, heavily relying on parallelization, some of those optimization patterns make sense in a different way than it's presented here.
Yeah. And also I would suggest reading the data locality pattern because specifically that sort of deals with, reading about data locality specifically because it deals with how a lot of these patterns, especially the decoupling patterns, a lot of them sort of leads to, or can lead to, harder to sort of see where your code is actually going, not just for you, but also for your CPU, especially in terms of memory management. And this sort of chapter really delves into why that is a problem and discusses how, for instance, if you're doing a component system, how it might be smart to, put all your components next to each other, irrespective of which game object they belong to, just so that when you're iterating through them, you are sort of accessing data in a way that is really more friendly for your CPU in terms of sort of performance. So essentially, because when you keep saying new all the time, what you're essentially doing with your CPU is that you're very often ending up creating sort of a view of memory that looks like that, which isn't really efficient, because ideally you would rather have something like that instead, because that's sort of easy to predict where everything ends up going. But yeah, I would give this book a read because it is written quite well and it tackles some interesting topics. I would also try to do a project where you go bananas with this stuff, because you really need, like, I can tell you that it's a super bad idea, but you won't really know that until you have actually felt the pain of doing it yourself, unfortunately. So, go and do that now, and not on your, well, at least not sort of in your work day, but doing it in school is perhaps a bit more acceptable. So, for instance, I went total overkill for our first Pac-Man assignment, which was 2D Pac-Man, and I created a component system for 2D Pac-Man, which is like super stupid because there isn't variation enough to justify it, and the result of that is that I don't know anymore what that code actually does, because it's sort of so overly complex for what it was supposed to do. It looks nice though.
But wouldn't that be good if you intend extending that project?
Yeah, but I wasn't.
Yeah, for that particular assignment, yeah.
So yeah, if you intend to extend it, then sure, but then you also know that you intend to extend it, and then you probably also know something about what you plan to extend it to. And if you don't know what you plan to extend it to, then you better go figure out what you plan to extend it to, because Otherwise, you'll probably just end up with sort of the wrong abstraction for extensibility anyway.
Yeah.
Just purely because, unfortunately, we can't really predict the future.
Sounds like a sensible book to give another lecture on data oriented design.
Yeah. Well, that's for later.
That's for later. That's fine.
Yeah. Do you have any questions first of all? Yeah. Then yeah. One last point, just I want to discuss like beyond this one. So tomorrow we're gonna have a lecture on animations, considering the popular demand. And by the end of the lecture, I want also to have a brief demo of Mitsuba renderer that might be useful for some of you, especially if you're going to work on material appearance, but even without that, it's kind of quick tool that helps you to visualize, for example, how your model with particular material properties would look like, to play with lighting, with different rendering techniques. So it's just like a tool implemented for you where you just need to put parameters and render and see how it looks. So I think it might be helpful. And next week, on Tuesday, we will have Vulkan talk by Carl. And yeah, thanks to him again for proposing the talk. And on Monday, like, we have this slot that was intended to be a Q&A for your assignment too. But like, I want to ask you, like, would it be beneficial for you if you have this Q&A session where we just go through where you stand, whether you have any problems, questions, or do you think it's all smooth and you need something else for that day? So what would be your proposal?
Q&A as in help with the assignments?
Maybe, yeah, for assignment too, yeah. Or maybe like something else from the course that you are not certain that you have got, or you want to.
Sounds like a good idea.
That is it.
I'm probably going to be stuck on something.
So yeah, that's exactly the intention to have that too. And or if there is any topic from the course that you want to revisit and just clear up before having the exam. So you think Q&A is helpful and useful for you? Or any other suggestions?
How is general progress on the project? Of the 5 people that that's right. Going somewhere, okay. Yes. Going somewhere? Both of you. Hesitant, okay. So we need to catch up on you. Okay. You? Oh no, he's out. Right, wrong one. So where's the rest of the class? Are we down to 6 people?
Yeah.
That's sad, isn't it, right? Are those
Sure, there's at least one more.
that would be
I
very
think
very
they're watching the stream. I have seen like
yeah, I'm just
some
kidding.
of them are
Of
watching, yeah.
course, there will be a lot more. But yeah, so that will be important, especially for Easter, because when is the deadline?
23rd of
Yeah,
April.
23rd.
So what is that? That is a few days after Easter, right?
It was Tuesday, right after.
It's 22 days.
Easter is on the 22nd or the 23rd.
Right. So not much time, is it? Around 3 weeks left, right? So bear in mind. So it's not really much time to get somewhere substantial. So I think it would be worthwhile that people latest by WEX we could at least show what they have already. Like it's more in a QA in the sense of not only where you start but also where your progress is, because we want to know and get you. Bear in mind, graphics doesn't work last minute. Most of you figure that out. Just a reminder there, in case there's this misconception. And Per-Morten made the point clear. A lot of the exam is probably done before the exam, right? So I mean, build a framework is a very good way. Luckily, you don't quite know. That's the challenge. What your framework is for.
Yeah, I mean, we were lucky. We were super lucky getting Minecraft after.
So it's a gamble. It's a gamble. You're not getting Minecraft. So anyway, it's totally a gamble. I will not repeat any of the past exams. So if you're talking to the senior citizens in this room, good luck. They will certainly they will help you to reduce the potential
space by excluding certain types of exams, but we haven't come up with your exam yet. So, but it's still worthwhile thinking about your framework, and it can be as simple as getting your game loop with some sort of rendering-based effects, bit of lighting going, or as complex as to have a complete modeling capacity and user interaction.
At least have stuff like loading shaders and compiling shaders, something going like that's the
Definitely.
That's the minimum.
The basic game loop with something showing on display, so you can go from there. I agree.
And sorry, to go also set up debugging tools. I don't know how many who's been using GFX or RenderDoc, but if you haven't, make sure that you're familiar with those for the exam.
Yeah.
Because it might be.
Don't learn them on the exam.
Yeah,
right? So
that's the last time we want to learn this on the exam.
So one of the things about the, at least as far as my experience goes with the different tools, if you play with them, use them on the working project first. So you know what the expected output would be if a project is actually properly running. Right? So then it's a lot easier because they have a lot of opportunity to select, to explore different stages of the pipeline and so on. Then you have a bit better of a diagnostic understanding, or kind of if you figure out the symptoms if something is not running. Right? If you start with a non-running project and look at it in the debugging tool, you may not be quite sure whether that's supposed to be like this, or perhaps not like this, or it's incompatible to your graphics card, or whatever else. So start from a working version and then use that as a baseline. But as Per-Morten says, know those things beforehand, know where to look, else you probably as good, well, as well off as not using in the first place, if you start doing last minute.
If you're doing it last minute, you're probably better off not using it at all.
Yeah, they confuse you like hell. Because they're simply generic, right? So they're made for any sort of purpose, for any sort of, well, nearly any sort of graphics card, so it makes it kind of make it a bit challenging to deal with those. So yeah, use that time wisely.
So yeah, frequent commit will help you like a lot. Like if you do this.
Of course, yeah, that's the professionalism, right? So in case you screw things over, do frequent commits, right? Sorry, I was interrupting you, but unless you're reinforcing your point, that's a very good point, especially in exam. And learn how to roll back, right, to all the commits as well. So and get it right. So you use it in your favor, right? You don't want to use the one single mega commit and hopefully everything works. That's the one case where we probably won't penalize you on the infrequent commits, but since you're penalizing yourself by not having a running project, that's the worst payoff you can get. Usually we look at the frequency of commits as a gauging of your professionalism, but it will just bite you in your back if you do it in the exam. So early and often. That's right. But we get to that back, right? So exam, we give them another pep talk, I think, when we get to close up to that time. And when we figure out what it's not and what it is possible. Does anyone have a wish what they want to do for their assignment? Exam, sorry.
For exam?
Yeah.
Minecraft.
Let's see a bit of the general gauging. You have active influence on the possible pathways. That's not the, of course, exam itself, but we know what you guys like or don't like, kind of thing. So is there anything that you have in mind? So this course is luckily not called game programming, but it's called graphics programming. And since loot boxes are considered illegal in Belgium now, we probably shouldn't adapt the idea in Norway. No, I'm just kidding. So you of course won't have the time, right? 72 hours. And we focus on what you've learned in the graphics course primarily, right? So gaming is of course a component, but a AAA title. Yeah, check in the third-year programming, game programming course. That's an angle. You can attempt it there. I think it's more realistic. Other ideas? No. Cool. They're very different about this.
Then they ask the other way around. What you don't want to do at an exam?
Say that you don't want shadows.
Just unrelated things.
No, that's very related. I mean, yeah, raw feature exclusion is an interesting one. Yeah, traditionally shadows was bonus anyway, right? So
yeah, I think that is the new exam. I think shadows was almost guaranteed by most spots.
Oh, really?
Yeah, but we also weren't going as far as we were going because we have more of the 2D stuff as well.
So anything you don't want, very good. Well, one thing you probably don't want is Pac-Man at that stage anymore. So that's
Well, we have to jump dimensions then, so it's 40 Pac-Man.
that would be 40 Pac-Man in 72 hours. That's interesting. Yeah, okay. Challenge accepted.
Oh, I mean, it's their challenge, so.
on the part of the class.
Yeah.
Since they don't give answers, I give answers. Okay?
Yeah.
So, because if they don't tell us what they want, we will tell them what we want. So, but anyway, if there's something, you know, some perhaps ideas or directions and so on, or features you want to explore more, or sort of interactivity you have thought about, but you know, okay, bring it in. But we'll see. Of course, we'll give you an example. Don't worry about it. But if you want to delineate the space a bit, you can do. Other thoughts? So we're nearly mirroring the number of students in that class. It's pretty, right? 4 to 6. I mean, if you play soccer, we still lose, but barely. You know, that's the thing. So let's hope some more people are actually watching on the stream.
Yeah, hopefully on the QA session, not show up.
True. Reinforce that tomorrow again on the stream, so to ensure that everyone shows up. That's right. That's a very good point. Next Monday. Because again, bear in mind, last chance before Easter, then it's getting kind of tough.
Should probably post that on the Discord channel as well.
Yeah,
So
right.
Yeah, would be good.
post it everywhere basically.
Yeah. Good.
Alright, tomorrow animations and Mitsuba, next week Q&A, and
Yeah. Thanks, Per-Morten. Bear those lectures in mind, they help you not only in graphics, right? So those are the lectures that we apply to cross-cutting in a way, where it's really about professionalism, because it's by no means constrained to graphics only, right? The use of patterns and architectural considerations, optimization for or against something, and knowing what to do. Right? So you should carry that on independent